Hello, welcome back to our YouTube channel. In this video, I'm going to be going over an FRQ from the AP Calculus AB 2022 free response questions. I'm going to be going over question 1, which is a rate problem, and this question requires the use of a graphing calculator. Without wasting any time, let's get into it. So the problem says, from 5 a.m. to 10 a.m., the rate at which vehicles arrive at a certain toll plaza is given by A of t, and then you have that formula, where t is the number of hours after 5 a.m., and A of t is measured in vehicles per hour. Traffic is flowing smoothly at 5 a.m. with no vehicles waiting in line. So basically, important things to remember are that A of t is the rate at which vehicles arrive at a certain toll plaza. T is the number of hours after 5 a.m. And currently at 5 a.m., there are 0 vehicles waiting in line. So let's go to part A. Part A says, write but do not evaluate an integral expression that gives the total number of vehicles that arrive at the toll plaza from 6 a.m., which is t equals 1, to 10 a.m., which is t equals 5. So when you're trying to find the total amount of something, so in this case, the total number of vehicles, what you always want to do is you want to integrate the rate. So in this case, you would want to integrate A of t from t equals 1 to t equals 5 in order to find the total number of vehicles that arrive at the toll plaza, because this will find your change from 1 to 5, from t equals 1 to t equals 5, and this will be determined, and the integral will help you determine the total number of vehicles that arrive at the toll plaza. So again, when you're trying to find the total amount of something, and if you have the rate, just integrate the rate. So for this question, I would have my integral 1 to 5. And remember, these are our bounds because t is the number of hours after 5 a.m. So at 6 a.m., 1 hour has passed, and at 10 a.m., 5 hours have passed. So you wouldn't use 6 and 10 as the bounds. So now you're trying to integrate the rate of t, and this is all you have to do for part A. This gets you your total number of vehicles that arrive at the toll plaza. Okay. This helps you get the total number of vehicles that arrive at the toll plaza from t equals 1 to t equals 5. Okay, part B. Find the average value of the rate in vehicles per hour at which vehicles arrive at the toll plaza from 6 a.m. t equals 1 to 10 a.m. t equals 5. So the average value. So in my previous video, I explained the difference between average value and average rate of change. In this case, rate of change does not appear anywhere. So immediately, you should think of this formula. 1 over b minus a, integral ab. And then you have your function you're trying to find the average value of. So in this case, this would be the rate. So remember, think of this as your area, basically, and think of this as your width. And then when you evaluate this, you get the average height of the function, which is the average value of the function, and in this case, which is the average value of the rate. So let's set this up. So it would be 1 over b, which is 5, minus 1. And then you have your rate, a of t, your bounds. And since this is a calculator problem, I would not solve this by hand, and I would actually pull up my graphing calculator. So let me go to calculate 84, so I can show you guys the steps. If you have a graphing calculator, just follow the exact steps here. So I want to plug this in. So I already have a of t plotted in here in y1. So what I would do first is I would click this y equals, and then I would plug in the formula 450 square root sine parentheses 0.62x, and then I would do second quit, and then I would do alpha fraction 1 over b minus a, which is 4. Then I would do math 9, plug in your bounds 1, 5, and then to access my function, I would do alpha trace, and then pick y1 because that's where I put the function. Right, and always remember to be in radians. And when you put this here, you get 375.537, which is your answer. Sorry, you get 375.536966287, but always round to 3 decimal places for the AP exam. And then units would be vehicles per hour, because this is the rate, and the units of the rate are per hour, vehicles per hour. Okay, that's part B. Now let's move on to part C. So it says the rate at which vehicles arrive at the toll plaza at 6 a.m. It's asking if the rate is increasing or decreasing at t equals 1. And it says to give a reason for your answer. So whenever you want to find if something is increasing or decreasing, if you want to figure out if a function is increasing or decreasing at a particular time, you need to look at the derivative and see if the derivative is positive at that time. So in this case, you'll want to know if a prime of t is positive at t equals 1, which can be rewritten as a prime of 1. So you just want to see if this is greater than 0 or less than 0. Okay, so again, I would use my calculator for this. So the function is already here, a prime of t. So to take the derivative on the calculator, I would do math 8, plug in my function, y1, alpha trace, and then click on y1, and plug in 1. This takes the derivative for you at t equals 1. And you get 148.947. So since the derivative is positive at 1, this means that the rate at which vehicles arrive at the toll plaza would be increasing at t equals 1, since the derivative is positive at t equals 1. So the explanation for this would be the rate at which vehicles arrive at the toll plaza at 6 a.m. Oh, sorry. Yeah, actually that's fine. T equals 1 is increasing at 6 a.m., which is just t of 1. Get rid of that. Because a of t, a prime of t, is positive at 6 a.m., which is t1. This is all you have to write, and this would get you full points. Yeah. Okay, so let's move on to 1D. 1D says a line forms whenever a of t is greater than or equal to 400, and the number of vehicles in line at time t for a less than or equal to t less than or equal to 4 is given by n of t. And then you have that formula there, where a is the time when a line first begins to form. So to the nearest whole number, find the greatest number of vehicles in line at the toll plaza in the time interval a less than or equal to t less than or equal to 4, and justify your answer. So immediately when I see this problem, I think I would begin and try to find what a is. So a line will first begin to form when a of t is first 400, right? So I would set a of t equal to 400. And we already have a of t, and you just have to set those equal to each other. So since we already have it in Calculate 84, you can just do it on there. This is what you would do. We already have a of t in y1, and in y2 just put 400. And then what you would want to do next, it doesn't let me graph it on Calculate 84, so I'll do it on Desmos. But I would do second trace, click on intersect, and then see when they intersect from 0 to 4, the first time they intersect from 0 to 4. And I'll explain why 0 to 4 in Desmos. So here's my graphs. So I said to look at when they intersect from t equals 0 to t equals 4, because the time obviously can't be negative, so you would ignore everything on the left part of the y-axis. And this intersection point, it's greater than 4, which is also out of our interval, so it can't be that either. So it has to be these two. But the first time the line begins to form would be at 1.46937, because that's when it first hits 400. So I would put A as 1.46937. Okay. So A would be 1.46937, and B, and this other part, which we're gonna just call B, this is gonna come in handy later, and I'll show you guys as we do the problem. Because the first time the line hits 400, it's at this, A equals 1.46937, which is your value for T. So now since you have A, let me go back to the problem. So for part D, it says find the greatest number of vehicles in line at the toll plaza. So this is a minimize maximize problem. So you want to maximize the number of vehicles. So what I would do, every time if I want to maximize or minimize something, I would go ahead and put a T-chart. And this is like your XY T-chart. So our X in this problem is T, and the function we're trying to maximize is N of T. And then here I would put critical points, and a critical point is when the derivative of the thing you're trying to maximize or minimize. So in this case, N of T. So N prime of T, you would want that to be equal to 0. a critical point is when the derivative is equal to 0. So you do n prime of t equals 0. And n of t is given to us as that over there, right here. So if you want to take we're going to have to take the derivative by hand. We can't do it using a calculator because we're not plugging in a value for t. So it would be a of t minus 400. And this is according to the fundamental theorem of calculus, because if you take the derivative of an integral, you just plug in the upper bound, which is t, into whatever variable is there. So there's x. So it just becomes a of t minus 400. The fundamental theorem of calculus states that. So you would want to set these equal to each other. So you would want to do a of t minus 400 equals 0. So this means a of t equals 400. And we already saw this earlier, if you noticed. So the 2 points were 1.46937. And now this is where the other point comes in handy. 3.59771. And I wouldn't round just yet. So I'll plug in my values for t. So 4, which is your critical point. I would label these. And then 1.46937, which is a, right? Oh, sorry. Let me put this like. Oh, this is an endpoint. Sorry, not a critical point. Apologies. This is an endpoint. These are your two critical points, 1.46937. But in this problem, we're just going to treat it as a. And then this is your other critical point, 3.5967. Let's just put it as critical point. Or here, we can actually do this. One second. Both of these are critical points, so we can just have like a big... there. Okay. So that is a, and both of these are your critical points. So all we have to do now, we just have to plug it in. And yeah, so all we have to do now, we just have to plug these values, t, into n of t. And this can be done using the graphing calculator. All right, so I would actually first put n of t here. It's actually, I don't have to keep going back to the actual questions. N of t is this, and then you have a of x minus 400 dx. Okay. So how I would plug this in the calculator would be do alpha trace y1 minus 400, and this, and if you plug this in, you should get your first value, so which is 62.338. And you have to plug in the other points. If you plug in 1.46937 for t, you're just gonna get 0. The bounds are the same, so it's gonna be 0. And then let's plug in our last point, which is 3.59771, and this gets you 71.254. So that is going to be our max, because that's the greatest value of n of t at that point. So now it says to the nearest whole number, find the greatest number of vehicles. So it would be the greatest number of vehicles in line at the toll plaza, and the time interval AT4 is 71. And yep, that's it. And yep, this was the FRQ, and thank you for watching.